Welcome back again. This next session will be again with Rustam. You probably already know him from the morning session. This time he will speak about data pipeline libraries in Java, which you can use to glue your applications together. So,
All right. Yeah, welcome back, everyone. And now I want to talk about something totally different. So in the morning we talked about like the best practices and things, how to develop and keep your projects healthy and happy. And now I want to talk a little bit about how to keep your data pipelines healthy and happy, and your data things like that. So I'm going to talk. I'm going to be talking about um, the data pipelines. But to make it a little bit more fun and more entertaining, I'm going to tell you a story of this pet project that I had. And there are two sides of this talk. So one of them obviously is to explain you how the things work and how you build the data pipelines with this library that I have been using. But the other thing, the other bit less obvious reason for this talk, I also want you to encourage you people to use your knowledge and use your abilities to write code and to do things to solve problems that you have in a bit creative manner as well. So there are two things to this talk. So I usually like to start this talk with a little bit of a demo to show you the kind of the vision or the end some kind of endpoint for this a project that I had. So I usually start with a little demo. Um, let's go. Let's see how that works. I hope everything is good. I hope we're okay. Let's see. Hey Google, what's the bike availability next to my house?
There are 5 bikes available at the moment. Based on historical data, the availability for this station will be decreasing for the next hour. I would suggest getting your bike within next 10 minutes.
All right, so it worked, and it's always fun. I hope you heard that the voice, the assistant voice thing in the background there. So what I'm going to talk about is this public service, like public bike service or whatever you call that thing in English. They're basically bicycles they can rent inside a city and bike around. And to tell you the story of how I solved this problem for myself and just had some fun with it, learning the tool that I used, I'll need to rewind a little bit. So this is now, and this is kind of the future point at some point where we have all these fancy things integrated. But then if you will rewind back, I think it's by this time, it should be around 2 years or so back in time. Um, um, so the problem. The bicycles that we had. So the ones you see here on the, well, as long as it's not flipping the picture and everything, on the right, so the blue ones that with a little bit darker background, those are the bicycles I'm talking about. Those are the ones that you have here in Oslo that you can rent bike with them for some time, and then you put them in similar lockers and you kind of give them back, right? This is from Oslo. So, but then on the ones on the left side, the red ones with a little bit lighter background, daytime picture, that is from Belgium. So that was when I was at Devox Belgium and doing the talk. So, but then, I mean, I've seen these bikes everywhere. I've seen it in San Francisco, in Madrid, in like everywhere, pretty much everywhere you go, you'll see something similar. And the idea is, again, you buy a membership and then you can use them. But then the thing is that, like in Norway, it's actually pretty nice. It's very cheap, and then you just, you can technically, theoretically, you can use them whenever you want. You just pay this little membership thing for half a year or for a year or whatever you want, and then you can use them as much as you want, as long as you kind of keep yourself within the time limits and the rules they set up and things like that. And the way to market those things is like this, right? It's The bicycles are there, you just pick one, and it's summer, it's nice, you just bike by the water, and it's green, and it's like, it's amazing, it's fantastic. And so I asked these folks, I was like, hey, I'm doing this talk about your public data and APIs and stuff, can I have some pictures? So they gave me some cool pictures like this. So this is pictures from the company doing this thing. So and it's another picture that I got from them that's also really, really nice. That's like Oslo, middle of the city, very, very close to where I usually bike and everything. So my idea was like, okay, fine, you know, if I get this thing, I can actually don't have to think about having my own bicycle, having my own lock with me, and, you know, making sure that it's not being stolen or anything. So I can just, like, you know, keep my bicycle locked and just use this for short trips and stuff. And it's really cool, and it kind of works in theory. In practice, it's a little bit, there are a few things that you kind of have to consider. One of them, that the weather is not always like that, right? It's Norway, so the weather might be a little bit like that, but I mean, that's okay. That's still okay, because they even have, in the winter, they have this kind of, I think, trial projects where they can, where you can still rent the bicycles with like special wheels and, you know, things like that. So that's fine. But let's go back to this nice weather. So this is a spring time. You kind of considering buying your membership thing, and you see this marketing pictures like that, and you're like, huh, this is going to be fun. This is going to be cool. And I just can, you know, do it as much as I want and everything. So you buy that membership thing, and when time comes to actually bike, to actually go somewhere, you kind of expect to go out, 2 minutes walk to the nearest locker. You're just going to find the bicycle there, and you pick it up and everything. So you expect pictures like that. So or expect the reality to be like a picture like that. In reality, so in practice, the reality is like a little bit different. So this is the same stop, which is right across the street from where I work, and that is how it usually looks. So I took both pictures myself, once just after they refilled the whole thing, and the other one was just a little bit shortly afterwards, when people just picked up the bicycles and there were no bicycles left. So this is kind of what you expect, and this is what you get, and it's a little bit sad. So when you meet this kind of empty bicycle lockers from like quite often or from time to time, you get a little bit sad, and you get a little bit like, oh God, you know, I just spent some money on this thing, and I was expecting to save time on this thing, and now I don't find any bicycle. I have to run between the stops to find a bicycle, and when I find a bicycle and come to my destination, I actually have to run around to find another locker which is empty, where I can actually put my bicycle, because otherwise I have not delivered it in a way, right? So that's where like most of the consumers would stop, and then they would be like, oh, well, you know, I have to look for that as a solutions. But then we as an IT people, and we, you know, work for, you know, get paid on a daytime for writing code. And then you realize like, hey, you know what, I can do coding, right? I can probably try to solve it in a way, in a kind of creative way. And this is what I want to encourage you as well, like try to solve daily problems with a little bit of code, and see, maybe you'll learn something cool and fun in the process, because for me it was this problem, and I also was I wanted to learn this tool that I'm going to be talking about. I was curious about how it works and everything. So then I was like, hey, I can use those two things and put them together. So I started hatching this master plan. And the master plan was the following. It was, okay, so there are no bicycles, right? That sucks. Where can I find one? Well, I don't really know. There are none here. Then I have to look for something. I have to look for a map, for an app, or for something that where I can see the other places where I can find bicycles. Well, can I use an app? Well, not really, because, well, there is an app, there is a web page, and there is everything, and it's really cool. But the thing is that it shows you real-time data. So if it shows me that there is 5 minutes walk from where I am right now, there is another stop, and it has a bicycle available, by the time I get there, the chances that it's gone, it's going to be a lot, because, well, there's just few bicycles available. More people want that, obviously, within, like, you know, going to work, from work, you know, it can be different things. It could be just nice weather, people going to the beach or whatever. So probably I cannot use the app, or at least get like definite results out of it. So, okay, can I use a public API? Can I use, like, do they have any API that I can use? Well, yes, they do. And that's exactly the one that is used by the app and the web page and the other things. And so that means that it has the same problem, right? So it will give me the right now picture, and that's it. So, well, but I can maybe still use for it, have like some kind of use for it. What can I do? Well, I can try to actually collect historical data, put them in the will, because obviously they have a lot of data about the usage and everything, but they don't want to, or they don't share everything with the consumers. But they have a public API, so I can actually go in there and dump data. And then I can store the kind of non-sensitive data, and well, they don't share any sensitive data anyway, but it's just availability data, so there is no personal information or anything. I can store that in somewhere and do something about it, I guess. Well, what can I use for storing that? Well, I mean, since I'm working as a consultant and I work in a like for the enterprise software and do things in a bigger scale, the first thought was like, oh, well, maybe we can go all full enterprise with data warehouses and stuff like that. But, well, you don't really want to do that, do you? Because, I mean, that's your pet project. You don't want to pay huge licenses and stuff for the things being hosted somewhere. You don't want to have like huge server racks at home or machines being on all the time just for the pleasure of biking for 5 minutes, right? That kind of doesn't really, it's really cool. I mean, don't misunderstand me. It's really cool to have a server rack at home, but it's probably not the top priority kind of thing. I mean, it's more that it's a really cool thing. At least I think it is, but I don't know. Some people, for some odd reason, might disagree. I don't know why. Well, it can be like that. So, can I write something? Can I write some kind of piece of code that can do that? Well, obviously I can, but then I can write a custom piece of code. I can write a Java class or a few classes, or I can write a Python or whatever, you know, Go. But then I have to do all the job manually. I have to use a library that will do the dumping to the from the web interface, from some kind of API. I'll have to do this to dump it to a file. I have to handle the reading from file. I have to do all those things, and I have to write all of the code myself, and I have to maintain it myself. And that really, again, you'll spend much more time playing around with your data than actually using it for something useful. So that sucks. So no, maybe not. Okay, maybe I should use something, and this is the sales pitch of this. It's open source framework, so I kind of, it's okay to do a little bit of that, I guess, for open source stuff. So something flexible, portable, and open source. Yay, you know, and yes, you can do that. And this is what what I ended up doing that, because it was a colleague of mine, or not, well, a friend of mine, he works for Google, and he was like, you know, he was like, have you considered this library? This is a really cool thing. And then I was like, huh, I have this problem, and this thing that you're talking about, maybe we can just, you know, do something about it. And then this is how this whole project started. And then you realize, hey, you know, you can, well, when I say profit, I don't mean money profit, but I mean, like, you know, you'll gain something from it. So you'll get to maybe use your bicycle or find a bicycle whenever the time is right and things like that. So a few words about myself. My name is Rustam. I live and work here in Oslo, Norway. I work at a consultancy company like during the day called Computas. I'm also a Google developer expert for cloud, so I work a lot with cloud and Java. That's basically most of the time I'm spending is on either of them, probably quite often together. And I'm also a Java champion as well, and I run a few communities and run GDG Cloud here in Oslo, and some other things, and organizing some events and conferences and things like that as well. So this is very short about myself. So let's go back to the problem. So I guess the first solution for this problem, or first attempt to solve this problem, was to run everything locally on my own machine. So actually to be To be honest, that was a slightly older Raspberry Pi that I had lying around that I just put things on it and just like set up a cron job that would dump the data from the public APIs into files 4 times an hour. So I had every 15 minutes, it would just, the cron job would wake up, ping the API, get the data, dump it to a file and store it. So it would have 4 files an hour, 24 hours a day for quite some time. And then the idea was like, okay, fine, then I can use something. So that was the kind of the first version of that I can use something like Apache Spark or something, a framework that can do that. I can dump into some kind of database. I'll call it a data warehouse, but depends on what you use for this kind of thing. And then I visualize it somehow, right? I can use Jupyter notebooks to do some kind of visualizations and plotting, or you can use, I don't know, even Excel or Google Sheets or something to visualize that. That was the first idea, the first kind of the premature, the first version of the version 0.001 or something. But then I thought like, okay, fine, but what if they at some point go from batch processing and batch files to streaming? So, or for example, if I want to process a streaming data of like weather data or something that's being streamed. So then I'll have to have another pipeline to process that data and put that together, because I wanted to see that if the availability, for instance, is being influenced by say weather conditions, right? If it's raining, nobody's using bicycles, or less people are using that, so there's more chances and blah, blah, blah. So then I would use something with like Apache Storm or something, and then I would put it in the same kind of data warehouse, and I visualize it again, and all those kind of things. But then, you have 2 different pipelines for 2 different transport methods for data. It could be the same data, it could be different data, probably different data, and then some point, maybe this bicycle people will start streaming their data. So, all those kind of things. So, but then I really didn't want to do that. I wanted to have something that can do both. And that was a really cool thing. And so I wanted to have both streaming and batch processing going into something, a black box that will do both for me and put it all into database. And so you kind of simplify things, right? And that's where I realized this Apache project called Apache Beam that was originally made by Google and open sourced by them at some point. And now it's an Apache Foundation project where there's a lot of people involved, and it's really fun kind of thing. And the cool thing with it was that it has support, as you might have guessed already from the kind of this talk, is that it has both batch processing, but it also can do streaming process streams as well. And the other cool thing is that it has different SDKs. So original one was first written in Java, and then at some point later the Python SDK appeared. So now you can do both, and quite recently they also announced, or they released, a Go SDK as well. And that's cool. So you can actually choose your language of preference. So I ended up using Java, and that's the examples I'm going to be showing will be in Java. But then, you can pick whatever works for you, for your project, for the time being at that time where you're developing things and things like that. The other cool thing is that it has a model, but then you can plug different runners to that model. So, for example, you can for direct for local development, you can use direct runner. You can also do, for example, cloud dataflow runner for the cloud stuff, for instance, on Google Cloud. And then you can have different like Flink runner, Spark runner, and all the other ones. Basically, it has these plugins to do all the magic. So it can do both decide how to run things, but it also it has this other plugins that will let you read and write your data to different platforms also without any, with one-liners, right? So reading from files or reading from database would be almost the same. You just need to configure it a little bit different. And the cool thing is that you can swap the components out, right? So you can have, like on one side, you have the queues that are coming in, or data, the way that it's coming in. And on the other side, you have things like, where you store the data, right? Where you put the data. It can be S3 buckets, it could be a GCS or Google Storage, or it could be Hadoop, or it could be your local files or whatever, you know. So I started with Raspberry Pi, and the reason I kind of considered to move to, for example, cloud, that we'll see in a second, was that at some point a few months later, my Pi died because I was just writing and using the SD card so much for this. It was a little bit too intensive for that thing. So the SD card died. So I almost lost, well, I think I lost a little bit of data because I did copy it before, but I did not. I think I lost a few weeks or months of worth of data at some point, but that's another story. So so that was the open source solution, right? So the one I had on my Raspberry Pi would be like a cron job that wakes up so at some point, does this dumping to a file, and then I would have a pipeline that would wake up and pick those files up and do something with it and put it into the database. Because the reason I wanted to have that was I wanted to change the data structure and change the data of what is coming in and out and do this pipeline. We'll see that in a second. So I ended up moving this thing to the cloud. So the cloud version was exactly the same. So I'll go a little bit back and forth. So you'll see it's almost the same. It's exactly the same architecture. It's exactly the same boxes. It's just have a little bit different logos. So we're going from kind of local version to a managed version of the same thing. So this is written on GCP. It does not have to be on GCP. It could be anything else. It could be any other cloud provider, but the names of the things might be different, right? So here you have some kind of cron job, some kind of serverless function that wakes up and does the job of dumping things to a file. You have some kind of version of file storage buckets, things like that stores that, and you have something, either a managed Beam service, like in this case, or a VM running Beam and running just Java code and everything locally, or anything like that would process all that and put it into some kind of database. It doesn't have to be anything special. In this case, as you see in a picture, I used BigQuery, but it could be anything. It could be Postgres, it could be whatever, you know. And then you visualize it somehow with the Jupyter notebooks, with whatever you use to visualize your stuff with. And also, technically, I could also do stream processing as well. I probably will not be talking much about stream processing, but I would like to start with the batch processing of these things today, just because we have a limited amount of time. So I would like to start shortly to explain what this pipeline thing is and how does this work. So what is a pipeline? Well, pipeline is, well, there is a Wikipedia definition always for that, but basically think of a pipeline as a conveyor belt. When you have a bunch of bolts and pieces and everything on one side, and you have a long conveyor belt, just like moving belt of things, and there are people working next to it, and at the end you'll have a shiny new car coming out, right? So this is a pipeline. This is a construction pipeline where you put all the pieces and bits and pieces, or you transform it even, like, you know, if you go all the way further, it's just a roll of aluminum, and then you do a lot of things, and then you have a frame, then you have doors, then you have a trunk and things, and just all of a sudden there is a car. So this is a pipeline. So it's the important thing is with a pipeline, especially well in Apache Beam, is that it has to be directed. It has a direction, so you cannot just go back, and it is acyclic. So there are no cycles. So you cannot just go in a loop. You don't have this loop things. But you can join. We'll see that also in a bit. Now, how do you write a simple pipeline? So if you think the simplest pipeline ever in Apache Beam, because Apache Beam can be very fancy and very complicated and a little bit hard to grasp in the beginning. At least it was my experience that I haven't used before, and I tried to learn it for a pet project. It takes a little bit of time. So I want to start with a very simple pipeline just to explain, and then we can advance a little bit more on top of that. So before I tell you the first of those 4 steps, I want to show you the data. So the data I had to work with was something like this. So we'd have a list of all stations And that was the availability data. So it would have an ID, it would have some information about availability, how many bikes are available at that station, how many locks are available. If I come with my bicycle and want to put it into that lock, how many locks are available there, and some other data. And all the way at the bottom that you cannot see on the screenshot, it would have a timestamp when it was updated. So they would have an updated @ stamp. So I wanted to go from this, which was not really database friendly or reporting or any kind of prediction friendly. I wanted to go from that thing into something like this. And this looked a bit more, this is how it ended up looking in the database. And that was almost the same thing that you've seen so far. But the thing is, now I actually denormalized or kind of put more data into each row, right? So now I have updated @ for each of the stations or each of the IDs, instead of just having it all the way at the bottom of the JSON file. So how do I do this? Well, this is a simple pipeline, right? So you do some reading from files, you do some kind of processing. We do this thing called parallel do. We'll explain that in a second. So basically, I'll explain that more very soon. But for now, it's something that can be parallelized without interfering with all the other things. You can just run it on many machines at the same time without breaking things for the other workers doing that job. So typically doing something with small piece of data that can be inside a Pardue. And then you store it to data warehouse and store it to database table. It ends up in the database. So simple pipeline, right? So the first step would be to define parameters for that, or options as they call it, for the pipeline options. So you start with this thing where you define a bunch of inputs, file where the input data will be. So if it's going to be files or databases and stuff, where you're going to put the output, you define things. You, for example, give it a name. You call it something. So like here, I see that I have a get station metadata input file option. Where the input files for the station metadata is. I give it a name with @ description. I give it a default string, so default value. If it's not provided by anything else, it will use the default value that you see there, and it also supports globbing. So I could have said something like bike data stations star.txt instead of just saying specific file. So it will just pick all of them. So it's kind of cool. And then you can do the other methods and options as well. So I think in my code, I don't remember, it's probably like 10, 15, 20 of them. I don't really remember the number of them, but you'll see the code is there as well available. So now when you define your pipeline options, you put it into a pipeline and you create it. So basically one-liner, pipeline.create, and then you push all these option things that you created in the previous step. The third step would be to actually, that's where the magic happens. That's where this conveyor belt, or this thing that where you have those workers along the conveyor belt doing things, right? Putting doors on the body and putting lights into the, where the lights are supposed to be, and wheels on and stuff. And you do that all with .apply. So you basically have your pipeline and you do .apply, do something, .apply, do something else, .apply, do something else. And then and that's the thing. So that's why you have a directional pipeline. You cannot just apply. You apply to output of the previous apply always. So it's always kind of changes a little bit. And here, for example, I start with the reading from text. So you see the first line does text.io.read, and then it will do some kind of transformations in the middle there. And at the end, it will dump it to file. So I do text.io.write. And you see I'm picking up the options from the options object in both read and write. So Pardues. Pardues is actually a cool thing. It's parallel do, as I told you, and it's an element-wise transformation. So you basically have something, you transform it to something else. But then it has to be something that can be parallelized without breaking the bank. So without breaking all things for all the other things. So in my case, it was just a transform where I would just convert a JSON object that I have, one object, to a data structure I wanted to be ready to be dumped to a database. Because, well, this is the thing. So you can read as many files as you want. You can pick as many objects as you wanted. You can transform as many objects as you wanted because they're not dependent on each other, and you can make them ready to be dumped to a database. So it's really cool. And then, so that's the first 3 steps. And then you have the fourth step where you actually run the whole thing. So this is an example using Maven, running it on my local machine, my own machine. With, as I told you, if you remember, that there was this thing called Direct Runner, so where you can run it directly on your machine. And this is so this is my own machine. And okay, fine. How would that thing look if I would go? Oh, that was a bit loud. How that would look if I would go to cloud. Okay, well, this is how it looks. So I'll go back and forth a bit between those 2 slides just for you to give you some time to compare. So what you see what's happening here is that for the cloud, it has pDataflow runner. So I defined the Dataflow runner. But for my local one, I have a direct runner. So the second line, technically, it will be different. Then I still provide a main class where the object's going to be and everything. That's cool. I also still provide some input stuff. And for the cloud, I need to provide a little bit more. So the input and output will be a little bit different because I will be pointing at buckets instead of local file system. And also I will also provide some things like a region and, you know, all those kind of different options for the cloud specific things, because I want to run this thing on a specific place in the cloud, right? Okay, so this is the pipeline version number 1. This is how it looked. So I read from files, I do something with it, I map elements, I write it to a database, and I drop it. I'm done. And this, as you can see, this is how it looked running on the cloud. So well, it took me, let's see, it took me 18 minutes and 40 seconds. And it was around 17 machines that kind of woke up, processed all the data, and dumped it to a database and were killed. And that was probably around 7 or 8 months worth of data. So 4 times an hour, 24 hours a day, nonstop. But then I wanted to do something a bit more different, right? So, well, this is the output, and then this is the first kind of take at this kind of database. So when I was processed all that, and I looked at the stats of the table where I stored all the data, the denormalized data, I had actually quite a bit of rows. I still already had 1.1 million rows with data, but it was nothing unlike data size, right? It was just 36, roughly 36 megs of data in the table. So that was not big data. There was not big anything. It was just a little bit of data in many rows. And then I wanted to do some more stuff. I wanted to denormalize it a bit further and do some other stuff. And because the thing is, like this thing that you saw on the side, it had an ID, but it had no explanation of what and where that station is and everything. And for my stuff, I wanted to have a little bit more data. So I found that they had another API endpoint where they would provide metadata about each station. So then you can map an ID, an availability, an ID in metadata, and then you suddenly had much more data about stations. You would have a name, an address, even geographical coordinates, and even a polygon drawn around the station on the map. So you can see the bounds thing on the bottom there that I don't think I used for anything, but it was fun to, you know, you had to use. You could use. And then I wanted to have even more denormalized output in my table. So I wanted to put all this data about each station for every row, because the stations might change, and they did change. Some of them did close down, some opened, some been moved, and things like that. So I wanted to have the historical data about the metadata as well. So then I wanted to dump all of a sudden 2 files every 15 minutes, an hour, and 24 hours a day. And then I wanted to join them all together. And that was another thing that I wanted to learn in Apache Beam. So sometime later, so now we're almost, well, probably a year, approximately more or less a year later, I ended up with 600 megs of raw files that I had on my disk or my storage, and I wanted to process all that now. So now I had almost, well, probably around 11 months or so worth of data for 2019 that I wanted. Yeah, it seems like it's till October. Yeah, so it's 10. Yeah. 600 megs. And now I wanted to, I did the same thing again. Now I wanted to process the two pipelines and join them at the same time, and at some point, and then do the thing. So now I'm doubling the work, I'm doubling the number of files, and I have 600 megs of files, so it's much more. And you can see here, I did this to run the same thing. So I start with two different pipelines, and I merge them at some point by ID. And to do that, it took me actually less time than before. We had 18 minutes. Now we had 14 minutes, so 4 minutes less. But then if you see the amount of machines that have been used for that, they're much bigger. So now we're at like 160 machines instead of 16 machines, so almost 10 times. But now we had much more data. So now we had actually, well, 1 gig worth of data in the database. And then we also had 13 million rows. Now we're getting somewhere. So now we have almost 2 years worth of data, and we can do some predictions and things and look at how things depend on the weather, on seasons, on times of the day, times of the week, and all those kind of things. And that was much more fun. So now I have even more data, right? So now I have also data for the whole 2020, which probably is well, I'm not going to show that. That's probably a bit weird because of, well, the different world we probably lived in. But now we had to process 600 megs of files, and I did that on cloud. So I wasn't really sure how much that's going to cost me, and I didn't really think about that. But the question was, the thing was that I got this message, and it doesn't show me how much it did cost me until sometime after the processing was done. I did not think about that. But then I got a message saying like, hey, you've used 900 more money. It doesn't say why, but 900 more costs you had for this month than you had previously. And then I got a bit scared. So now we can actually think about a number that is behind this little black box, but it's in euros. So and I was like, oh, this is going to be expensive. It can be expensive, and I didn't think about that. So that's probably, I hope I have coverage on my card. The number I got was 3.4 euros, even though it was 900 times higher than I had. So basically, I paid a few cents for storage because I had a lot of files there. But the whole processing job of 160 machines working for 15 minutes, give or take, that was just basically around 3.5 euros. And that was really, really crazy. I mean, this is not a part of this talk, but it's more of like, the data pipelines and processing is not really expensive. If I had to run it on my machine, it will take probably more in just electricity, even maybe, but it will take much longer time than 15 minutes as well, right? So think about that where you run your things when you process things and how heavy on processing they are. Sometimes if it's heavy processing, it's probably going to be a bit more expensive, but yeah. Well, and then instead of being the sad puppy that you had a picture of earlier in this talk, I was a bit more like this. I was a little bit more of an amazed monkey, and I was like, oh, wow, this was, first, that was easy. And second, if I run that thing on a cloud, that was really, really cheap. And that was kind of cool. So now we had this big picture of, this is the big picture we started. And now we had this, where we would do a batch processing, put it into a pipeline, put it in data warehouse and visualize it. And then there is also this concept of going from a batch to stream. I'm not going to talk too much about the streaming part because, well, because of the time constraints. But basically, the thing is that instead of going like Monday, Tuesday, or whatever you have in different files, you just continue. You just have continuous stream of data, and the data might also arrive at not exactly the same points, because with the files, you know that what's in the file, it's in the file, and that's it. And if with streams, you might have data arriving for example, say 8 o'clock at 8 o'clock, but it can also arrive later and can arrive much later. And what I can say is that the Apache Beam has some cool ways of handling that as well. So it has these things with transformations we talked quite a bit about, but it also can also provide windowing, watermarks and triggers for data that comes in at some points, and also it can do some accumulation and things like that. So there are different ways of also transforming your data, and so you can do it just by each element, or you can aggregate them, or you can do some kind of composite or mix of things. You can also provide windowing, which you can do in Apache Beam, where you just do it by time. And you can do also some kind of accumulation, but sometimes you don't want to do accumulation or windowing by time, but you can do, for example, by sessions. So that's also a possibility there as well. So I want to mention a few cool features that I've kind of stumbled upon, and that really amazed me how simple it is to do in the code. And one of them is this windowing thing. So you can just do when you do events, when you process your events, and you just do .apply sliding window of a duration of 5 minutes every 1 minute. And that's basically just one liner that I put in several lines just to make it pretty and readable. But basically that brings me the data for 5 minutes in the past every 1 minute. So every 1 minute it looks at the data and looks back 5 minutes and brings me the data, and then I can process it and do stuff with it. Another cool thing is that you see there is a link to the at the bottom there to a blog post I wrote, was that there was no visualization locally. So the big, pretty visualization things I've seen, they're from the cloud, but there is no way of seeing that, at least in a simple way, when you do things locally. So I ended up deploying things to the cloud just to see how my pipeline looks. And sometimes you make errors, so your pipeline looks not the way you intended, and things like that. So you have to redeploy and blah, blah, blah. So it's not really fun. So it was annoying me quite a bit. So I did a little bit of digging. I found a very simple way to dump it to a dot files and then process those dot files from there. But it was not very well documented. So I ended up writing a blog post about that. So it's code-wise, it's very simple. It's a bit difficult when you don't know it exists. So yeah, and the other cool thing is that when you actually replace things, you can actually it's a very simple process. So you can just, instead of storing things to file, you just do another apply and you store things to a database. So for example, this one was storing, as you can see, the last two applies would make sure that you store things to a to a file system. But if you replace those two with two different kind of applies, you now all of a sudden dumping things to a BigQuery. It's a little bit of a lie, that slide. So there is a little bit of setting up you have to do for BigQuery, but that's how it is for a database. You have to provide schema and tell you what what the different attributes and data types and things like that for that. But that's kind of the setup for the database, and that's expected really. But transformation wise, pipeline wise, is just 2 lines of code. The other cool thing is that you can also dump it to other databases. So a colleague of mine, he's really big fan of this other open source database called DB, and he was like, hey, give me the data and give me the stream of data, and I can do something with it. And then after a few 5-10 minutes of clicking, he created out of the box, very simple, a little bit ugly, but it was 10 minutes work, a map with all the stations on a map, and it would show average availability for the last whatever, as long as we had data and things like that. So the simple thing is that the point is that you can replace parts of your pipeline and dump it to some other things and just create new stuff. So yeah, now I had quite a bit of data. Now I could actually do all this reporting and trends and things that you saw in the beginning of the talk, and many other things. So we ended up writing queries like this. So this is like very long query that you see going all the way down to you cannot really even see the whole thing, but then it would just give you, for instance, average availability at a specific stop, broken down by month and day of the week and hour and station and things like that. So then it would actually, then you will know, okay, are there any bikes at that stop at all, or when they're more likely to have some, and things like that. And all that was just because we had dumped all the data and processed it in this kind of simple way. And then you're back to being this amazed monkey thing. A few words of warning before we kind of finish is that it is still some kind of, think of it as a ETL pipeline, so extract, transform, load. It will still break if your data changes. So for me, what happened was that a very simple thing happened. They updated their backends, and suddenly they changed from regular JSON to prettified, pre-printed JSON. It broke the whole thing because, well, Apache Beam does not support the line breaks inside the files because, well, it's made to be parallel processable, and it cannot just, it's kind of made to read one line and do something with it, and read the next line and do something about it. So if you have like multi-line JSON files, it just breaks. So things like that, data will change, things will change, and it will break your pipeline. So it's not an absolute silver bullet, but it's as nice as you get without maintaining your own code for reading and writing and things. Most of those are written for you, and even cloud integrations and managed cloud services and stuff are available for you. The cool thing is that, yeah, well, so this is the architecture. Now we could actually process both streams and batch processing, put it in all the same pipeline, put in data warehouse and visualize it. Finally, I would like to say that it's all on GitHub. So this example, my pet project that I've been playing around with, which is just like my evening, whenever I have time kind of thing, it's on GitHub. So you can have a look, and it has some simple data samples so that you can run this whole code with and see how it works. And also I have, I've been experimenting a little bit. So have a look, play around, and you can also, well, see if you can learn something from those. By now, I think I will say thank you for being here. Thank you for organizing the whole thing, to organizers. Thank you for this, the participants for being here. And well, if we have any questions or not, I'm not really sure. It's up to, I guess, organizers to decide. But yeah, you'll find me on Twitter. This is my Twitter handle there under thank you. And there is also my email and the blog there on the picture. So ping me whatever works for you. Thank you very much.
Thanks for the second presentation. I see that there are no open questions, and our next session is in 7 minutes.
Yeah.
So see you again, I think, tomorrow, right?
See you tomorrow. Yes, I have another session with a colleague of mine. So we're going to be a little bit deeper dive into the cloud world tomorrow. So thank you very much for having me.
Thanks for
we have one question.
Oh, we have one question. Okay.
Yeah, just appeared.
Perfect. Where are you going to read that, or
in what degree is code coupled to cloud provider? What's the required effort to migrate such solution to another cloud provider?
It depends on what you use. So basically, the pipeline I have never really changed. So the code I showed you to run it, that's why I was switching back and forth. So the pipeline and code was actually the same. I never made any changes. So I just changed a few parameters to the way I run. So it depends on the you use different runners for different clouds. So for the local runner and the cloud runner, it's just the runner that is different. And Well, it's very simple. It's very well integrated with Google. I think I saw at Apache Beam quite a few presentations where they used it. Also, it was quite well integrated to things on AWS, for instance. So there are ways of porting it, but then if it's not integrated as a managed service, so basically the data flow that I showed here is a managed version of Apache Beam instances. But if it does not work, you can just, to move to another cloud or to move to another thing, you can do the simplest way of just running a VM and just putting it all in VM, and it should work. So I hope it answers the question. So yeah. If it's managed, if it's supported, just change the runner and it should work with very, very little changes. If it does not, just run a VM. I see that Oleg is here. So hi, Oleg. I'll leave the stage to him now, but ping me on Twitter if there is any other questions or comments and stuff.